So when we think of molecular models and we talk about bonding, the reason we talk about bonding is we want to think about those molecules as being organized atoms arranged in a specific manner rather than just atoms clumped together in any kind of particular or non-particular random way. So when we talk about models, there are a couple of things we need to keep in mind when we're describing or when we're referring to models. Models are based on experiments. Models are not perfect. Models allow us to make predictions, and models are somewhat simplistic. They allow us to see perhaps some part of the concept, but not the whole thing. So we've been talking about bonds, we've been talking about types of bonds. Formal definition of a bond, we're going to define it as one pair of shared electrons between two atoms in a compound. Anytime I'm forming a bond, I need at least one pair of electrons. If I have multiple bonds, then I have more than one pair of electrons. So multiple bonds mean I have two or more pairs of electrons between my two atoms. We're going to take a look at some models for describing molecular structure. We're going to start with Lewis structures. Lewis structures are very simple. They're two-dimensional. They're paper and pencil representations of molecules. And when we talk about Lewis structures, we're going to use the valence electrons. Valence electrons, remember, are the electrons in the s and p orbitals of the atom. So if we look at these elements and identify their valence electrons, we're going to use dots to represent electrons. And we have four sides to each atom, so we're going to use those four sides to help us organize the 8 valence electrons maximum available for an atom, for the most part. So hydrogen has 1 valence electron. Sodium has 1 valence electron. Does it matter which side I put the dot on? No. Oxygen has 6 valence electrons. The pattern, though, you do need to follow is you put 1 electron on each side first before going back to double up. And when you double up, usually the doubled electrons are put opposite each other, but they don't have to be. Chlorine has 7 valence electrons, so all the electrons are going to be paired except for 1. Does it matter which one is not paired? No. Argon's a noble gas. Argon's got 8 valence electrons, so each side is going to have 2 electrons. So drawing Lewis structures for atoms is really easy. How many valence electrons does it have? Count them up, put them around. Gets a little more interesting when we're making compounds. So we have hydrogen and we have fluorine. Each hydrogen has 1 electron, and I need a pair of electrons to form a bond. So I'm going to put that pair of electrons between the 2 hydrogens to show that a bond is formed. Each fluorine has 7 electrons. Need a pair of electrons between them because fluorine has a single bond. And of those 14, I now have 12 left. So I'm going to put 6 around each of the other sides of the fluorine atom. And there is my Lewis structure for fluorine molecules. Now when I'm doing Lewis dot structures or Lewis structures for compounds, there are a couple of rules that we need to follow. First thing I'm going to do is I'm going to sum up the valence electrons. So if I start with hydrogen, I'm going to take the number of valence electrons from each atom. So hydrogen has 1. There's 2 hydrogens. So here's the first hydrogen, here's the second hydrogen, here's oxygen's valence electrons. I add them all up. I have 8 valence electrons for water. Next thing I'm going to do is I'm going to put 1 pair of electrons per bond and put the bonds in. You can draw bonds as bars like that. A single bar represents a pair of electrons. Now I have to put the rest of the electrons in. Hydrogen can't hold or have any more electrons. Oxygen can. Oxygen is a p atom, and it is p6. So it actually is an element that can have an octet or have 8 electrons associated with it. So if an atom can have an octet, we want to make sure that they do possess an octet. So I've used 2 of my 4 pairs. I have 2 pair left. So those 2 pairs are going to go on oxygen. And you're going to be asked, you will be expected to, if you draw Lewis structures, show lone pairs as dots, not bars. So there's a lone pair, and there's a lone pair for oxygen in water, and so there's our Lewis structure for water. Okay, so I'm going to check the count. I have 4 pairs of electrons times 2, that's 8 electrons. Works for me. So let's take a look at these compounds, see if we can draw some Lewis structures, and work through a couple of them. We've seen carbon dioxide. Let's take a look at ammonia. Nitrogen has 5 valence electrons. Hydrogen has 1, and there are 3 of them, so I have 8 electrons. When I have an atom that is a singleton and multiple copies of another element, the singleton in general goes in the center. So I'm going to stick nitrogen in the center, and I have 3 hydrogens surrounding it. That looks like they're surrounding it. Now I'm going to draw in my pairs for bonds first. So I have 8 electrons. 3 of those pairs take up 6 of my 8 electrons, so there's 1 pair, 2 pairs, 3 pairs. I have 1 pair of electrons left. Nitrogen's a p element, and it is one of those p elements that can have an octet, so it should have 8 electrons associated with it, if possible. I've got 1 pair left, so it's going to go on nitrogen. So there's my Lewis structure for nitrogen. If I look at boron trifluoride, boron has 3 electrons, valence electrons. Fluorine has 7 times 3 is 21. So I have 24 electrons. Boron is going to be in the center, and I have 3 fluorines. 24 electrons mean 12 pairs. So 1, 2, 3 of my pairs are going to form bonds. So I have 9 pairs left, so that means 18 electrons. So I'm just going to start putting electron pairs around my fluorines because fluorine needs an octet. Boron is in a 3. It can only have a maximum of 3 bonds attached to it, so 6 electrons. It cannot have an octet. Columns that can have octets start with carbon. All right, let's look at nitrogen, because nitrogen's a little interesting. Nitrogen has 5 valence electrons, so nitrogen has 10 electrons, so I have 5 pairs. I only have 2 atoms, so I put 1 pair between them. Now I have 4 pair. I put a pair here and a pair here. I have 2 pair left. Nitrogen is an element that needs an octet, so I need to make sure it has 8 electrons or 4 pairs associated with it. I only have 2 left. If I put both pair on the left nitrogen, the right doesn't have enough. If I put both of them on the right hand nitrogen, the left one doesn't have enough. And if I put 1 on each, neither of them have enough. So I solved the problem to make sure that nitrogen, each atom has an octet by putting both pairs in between. And so now the left-hand nitrogen has 1, 2, 3 pairs that it shares plus a lone pair. It has an octet. It's satisfied. Same is true of the right-hand nitrogen. It has 3 shared pairs and a lone pair, so it has an octet, and it is satisfied as well.